Have you ever wondered if the universe had a beginning, does it also have an end? After all, everything that has a beginning also has an end, right? So, how can something finite, like the universe, become infinite? Or if the universe is expanding, what does it mean for it to expand into infinity? These questions challenge our understanding of the universe. Today, we'll dive into some mind-bending ideas, the curvature of the universe, the nature of time, and the reality we experience. We'll explore how can the universe be finite but infinite at the same time, and why this idea isn't as strange as it might seem. Let's start with a simple idea we can all visualize. A circle. A circle is a finite shape, but its surface has no true end. It's limited in size, but it keeps going around in a loop, constantly expanding outward without ever having a final edge. Now imagine the entire universe is like that circle. It's finite in some sense, it has boundaries, but its curvature allows it to expand endlessly, never reaching a true final edge. This concept challenges us the way we usually think about things being either finite or infinite. But the universe may not fit neatly into either category. It could be finite in size, but infinite in expansion. And the key to understanding this paradox is the concept of curvature. But here is where it gets even more intriguing. Time itself is intertwined with this expansion. When we talk about space expanding, we don't just talk about three spatial dimensions, x, y, and z. Time is expanding as well. Just as the universe's physical dimensions grow, time stretches and expands. This means that as the universe gets bigger, time flows differently, even if we can't always perceive it directly. So, how can something finite, like the universe, become infinite? We often think that limits and boundaries are inherently linked to finiteness. But with curvature and the expansion of time, we begin to understand how the universe might be finite in size yet still expanding infinitely within its own curved space. A good comparison here is the number pi. Pi is finite, but its decimal expansion continues forever. Consider this idea: an finite series where the total sum never exceeds a certain limit. 2 is a finite number, right? Even though the terms go on forever here, the total sum never exceeds 2. This demonstrates how something finite can lead to an infinite process. Similarly, the universe, although finite at its beginning, could continue expanding infinitely within its own finite structure. Now, let's add another layer of complexity: time itself. We often think of time as a smooth, constant flow from the past to the present and into the future. But what if time does not move as evenly as we think? Physicists suggest that time might not flow in a constant linear way. Instead, it could have pockets where time moves faster or slower. These fluctuations could explain strange phenomena like déjà vu. When we experience déjà vu, we might feel like we have already lived the moment before. What if this isn't a simple memory error, but a sign that time itself has small irregularities? These fluctuations could be tiny shifts in time, much like how space can curve. Imagine you are driving in a car. You cannot see how fast you are going because you are inside the vehicle. Similarly, we are inside time, so we can't always perceive its flow. Perhaps those moments of déjà vu occur when time itself has tiny shifts or fluctuations, making us feel as though we have already lived the moment before. This brings us to another intriguing possibility: time travel. Could we travel backward in time? Many physicists think that space-time, the very fabric of space and time, could bend or stretch in a such way that time travel becomes theoretically possible. The idea is linked to the curvature of space-time. If space itself is curved, could time be curved as well, allowing us to move forward or backward in time? So time travel is not just science fiction. It's a logical extension of how space-time can behave in strange and unexpected ways. Now let's venture deeper into the unknown, our perspective on the universe. Our understanding of reality might be fundamentally limited. We live in a three-dimensional world, perceiving everything as if we are on the surface of a three-dimensional sphere. But we are constrained by this perspective, unable to see the larger structure of reality. It's like trying to understand the surface of the entire Earth while only seeing a small patch of it at any given moment. We can never step outside of our vantage point to observe the whole picture. These recent years, quantum physics has taken us even further into the unknown. Theoretical physics suggests that the universe could have as many as 11 dimensions. These dimensions are beyond the three we experience every day, and they might be woven together in ways we can't directly perceive. Now imagine a point in space that can fold into two-dimensional, then three-dimensional spaces, and eventually these higher dimensions could become so compacted and intertwined that they are impossible for us to observe. This could explain why our understanding of the universe feels so limited. We are constrained by the dimensions we can experience directly. Our inability to perceive higher dimensions could explain why certain phenomena seem impossible or mysterious to us. We may be looking at the universe through a tiny window, unable to understand its true nature. And here is where an interesting thought comes into play. What if we can't perceive the curvature of the universe simply because we are part of it? Think of it like the hands of a clock. The clock hands move around the face, but they can never see the movement themselves. Similarly, we are inside the curvature of the universe and can never fully perceive it. Our view is limited and we are restricted by the very structure we exist within. Just like a clock hand that cannot step outside of its circle, we cannot step outside of the universe to observe its entire curvature.